Hello, our course today is physics, and the topic is motion. Our topic for today is what? Motion. By definition, motion is the change in position. Motion is the change in position of an object or a body with time. So by simple definition, motion is the change in position of an object or a body with respect to what? To a time. So motion occurs with a given time. So in layman understanding, we can simply say motion is just like a movement. So motion, let's say we have a body here. We have a body here. This is a body at this point A. Point A. This is a body. This is point B. This is the movement of this body from point A to point B is a motion. And it takes a certain time. It can take, maybe from this point can take a seconds, to this point can take another seconds, making 2 seconds. To this point can take another seconds, making 3 seconds. So motion, by definition, is simply the change in position of an object or a body with respect to time. So we have what we call the equation of uniformly accelerated motion. So any uniform motion or a motion on a straight line has an equation. So we have 4 equations of a uniformly accelerated motion. Equation 1, we have V is equal to U plus AT. This is the first equation of motion. Number 2, we have S is equal to UT plus half AT square. Number 3, we have V square is equal to U square plus 2AS. These 3 equations are the major equation of motion. They are the major equation of motion, but we have a minor equation of motion, which is S is equal to U plus V all over 2 bracket T. So these are the 4 equations of motion. We have V is equal to U plus AT. We have S is equal to UT plus half AT square. We have V square is equal to U square plus 2AS. We have S is equal to U plus V all divided by 2 into bracket T. So these are the 4 equations of motion. So I'm going to be defining each parameters here so that we'll know what each of these symbolize or what each of them stand for. We have first, we have V. V represents what we call the final velocity. V represents our final velocity, and the unit of final velocity is meter per seconds. We have U. U represents our initial velocity. Our initial velocity. The unit of initial velocity is also meter per seconds. So let's take note of all these parameters carefully so that we know how to apply this equation. First, we have our V. Our V is final velocity. The unit is meter per seconds. We have U to be initial velocity. The unit is meter per seconds. We have also acceleration of the body. A is acceleration of the body, and the unit of acceleration is meter per second square. We also have, this is V to be final velocity, meter per seconds. We have U to be initial velocity, meter per seconds. We have A. We also have our T, which is time. Time, the unit of time is seconds. So T in physics can denote several things. T here, small letter T, denotes time. When you say capital letter T, you can say maybe it's temperature or period. but t here denotes time, and the unit is what? Seconds. Then lastly, we have our s. Our s is distance, and the unit of distance is what? Meter. So these are all the parameters we have here. We have our v, final velocity, we have our u, we have a, we have t, and s. So these are the parameters we have from this equation of motion. Now, there are few things I would like us to take note. I'll be giving us, before I solve question, I'll give us 3 things to take note. One is, we've talked about motion. It involves change in position of a body. Now, the first thing we should take note number 1, if a body begins from rest, whenever you hear a body, you might have encountered some questions, or you see some questions where they say a body begins from rest. Whenever you see a body begins from rest, take note that your initial velocity, your u, will be equal to 0. Your initial velocity must be what? 0. When you hear a body begins from rest. So take note of that before I solve any example. Number 2, note, when a body comes to rest after undergoing a motion, when you hear that a body comes to rest, a body moves from here to here, it now come back to rest. When you hear something like that, that means that body has an initial velocity. Therefore, its final velocity v is equal to what? 0. That is 2 things you must take note very well in motion. Number 1, when a body begins from rest, your initial velocity is what? 0. When a body comes to rest, your initial velocity is what? Your final velocity is what? 0. So, number 3 things, the 3rd thing we should take note in motion is what we call retardation. Retardation is simply a negative acceleration. That is, acceleration can be positive and acceleration can be negative. So when acceleration is negative, it is what we call the retardation or deceleration. So when a body is moving and a body comes to rest, so it's a type of this retardation is a type of acceleration that brings a body to rest. So that is what retardation is all about. So in retardation, our A is equal to, or let me say, retardation. In retardation, A is equal to minus A. It will no longer be A, it will be minus A. So whenever you hear that a body is moving and it comes to rest with an acceleration, that acceleration is referred to as retardation. So these are the very important things we should take note in motion. 1 is our initial velocity. Initial velocity is 0 when a body begins from rest. Our final velocity is always 0 when a body comes to rest. Then our acceleration is negative when retardation occurs. And retardation can occur when maybe a brake is matched. Maybe you are moving with a vehicle with a certain velocity. Then maybe a child just tried to cross your path. Then you match brake. So that brake is bringing you to a rest. That is retardation. So it is negative acceleration. So I'll be giving 2 examples. Example 1. Example 1. A train with an initial velocity of 20 meters per second. The train has an initial velocity of 20 meters per second. That is solution. Let's solve it together. Now, the first thing in solving question is to list your parameters first. So, a train with an initial velocity of 20 meters per second, that is u, is what? 20 meters per second. Is subjected to a uniform deceleration of 2 meters per second square. Deceleration, that is a retardation, that is negative acceleration. So our A here will not just be 2, it will be what? Minus 2 meters per second square. The time taken to bring the train to a complete halt is, that is, the time taken to bring the train to a rest, that is t, is unknown. So these are the parameters we are given, but there's something that we are given that is unknown from this question, which is our what? V, our final velocity. Don't forget, two things you must know. Among those things, the second one I said, when a body is coming to rest, since the train is coming to a complete halt, that means our V there will be what? 0. So I have V, I have U, I have A, I have T. So which of these equations can I use? Looking at them, that's why you need to list your parameters. You have U, and I have U here, I have A, T, and V. That means I can use the first equation of motion. So from the first equation of motion, V is equal to U plus AT. Our V is 0, our U is 20, plus A is 2, is minus 2. It's not just 2, it's minus 2. Minus 2 multiplied by what? T. So this is 0 is equal to 20. This is minus 2t in a bracket plus minus 2t, because this is minus t, 2 multiplied by t give us minus 2t. So this is 0 is equal to 2 minus 2t. So I can bring this minus 2t to this side, and whenever anything is crossing this equal sign, the life will not remain the same. That is, if it is minus here, it will surely become plus here. So since I have minus t here, it will become 2t plus 2t is equal to 0. Therefore, t is equal to 20 divided by 2. Then t is equal to 10 seconds. So what I did here is dividing both sides by 2. So our t is 10 seconds. So this is the first example. Now, I will give one more example. But please, if you have watched me to this point, do it to like, subscribe, and share. Now, example 2. Example 2. Calculate the total distance covered by a train before coming to rest if the initial speed is 30 meters per second with a constant retardation of 0.1 meter per second square. Now, let's solve this together. Solution. The total distance covered by a train before coming to rest, that is, the train has a velocity before coming to rest. So the initial velocity is what? 30 meters per second. So with a constant retardation, that is a retardation, negative acceleration. So 0 minus 0.1 meter per second square. So from here also, these are the parameters given. Then we also have our V. Since the body comes to rest, whenever a body comes to rest, don't forget that your final velocity will be what? 0. So we are asked to find the total distance, that is S. The total distance, S. So with all these parameters, you can look for the equation of motion to use. When you have U, you have V, you have A, we have S. Which of the equation of motion can we use to solve this? So equation 3 can do that for us, which says that V square is equal to U square plus 2AS. So when I have my V square, our V square is 0 square. U square is what? 30 square plus 2 multiplied by A. Our A is minus 0.1. Our A is minus 0.1. Then multiply by S. So from here, 0 square, 30 square give us 900. So this will be equivalent to 2 multiplied by 0.1 is 0.2 and S. So from here, 0 square is 0. And this is 900 minus 0.2 S. So I can decide to take 0.2 S to this side. So it becomes plus 0.2 S is equivalent to 900. So by dividing both sides by 0.2, divide this side by 0.2. our s will be equal to 0.2, will go with 0.2. Our x is 4,500 meter. So this is our total distance covered. This is the distance. Distance is the unit of distance is in meter. Please don't forget to like, subscribe, and share. Thank you very much for watching. God bless you.